The one-point Michigan cone test derives its name from the fact that the test was originated in Michigan and that only one mold is needed to be compacted. The one-point Michigan cone test is used to determine the max density of granular soils having a loss by wash of 15% or less. This includes aggregate base courses and granular material classes 1, 2, and 3. Here is the equipment required to perform the one-point Michigan cone test. The one-point cone mold, the blue side of the cone test chart, a pounding block, a plastic jug for water, a cone stopper, a spoon, and a sample pan or bucket that can hold approximately 3,500 grams of material. For the one-point Michigan cone test, soil moisture content shall be between 5% and optimum moisture. If the sample obtained is outside this range, it would be necessary to either add moisture to the sample or dry the sample and completely mix it prior to attempting to place this material into the cone. Material used to establish a max density comes from beneath the in-place test, approximately 3,500 grams or more when needed. The weight and volume of the cone mold are located on the bottom of the cone. Never change these numbers out in the field. You can check the weight by weighing the cone empty, and if the weight is off by more than 10 grams, request a new cone, or have a qualified person recalibrate the cone for you. You can try cleaning out the cone by putting 3 to 5 rocks inside and shaking them around to try to loosen up the hardened material. The volume and weight of the cone is recorded on Form 0582B. In this example, the volume of the cone is 0.0439, which is recorded into column C. The weight of this empty cone is 1,973 grams. Enough soil is placed in the cone to fill it about 1/3 of its height after compaction. It is then pounded 25 times or more by raising the cone above the wood pounding block and striking it sharply and flat on the wooden block. A second layer is added, filling the cone another third to about 2/3 of its height after compaction, and then pounded another 25 times or more. The third layer, which fills the cone to the top, is added and pounded another 25 times or more.
After filling and compacting the 3 lifts, there will likely still be some room for soil. Continue adding material and striking at least 10 blows each time material is added, until no further consolidation occurs.
A common error in this test is to discontinue the blows before you are certain that no more material can be compacted into the cone. If free water appears at the top of the cone, the material is saturated. The sample's moisture content should be reduced and the test repeated. After the cone is fully compacted and no more material can be added, the top of the cone is leveled off using a straight edge or the stopper. This is showing the cone leveled off at the top. Make sure that you wipe off any fine soil shavings that are stuck to the side of the cone. The cone is then weighed to the nearest gram and recorded under the remarks section of Form 0582B, Moisture and Density Determination. In order to verify that the maximum consolidation has been obtained, the following procedure shall be followed. This is commonly referred to as the 2010 rule and is used to determine the correct endpoint for the one-point Michigan cone test. A handful of material is added to the top of the cone, and the cone is pounded an additional 20 times. The material is again struck level, and the cone is re-weighed to the nearest gram. The weight obtained is then recorded in the first box of the 2010 weights section in the lower left corner of the 0582B form, and compared to the previously recorded weight in the remarks section. If the most recent weight is more than 10 grams greater than the previously recorded weight, then maximum consolidation has not been attained and will need to do another 2010 test. Upon completion of the second 2010 test, the cone is again struck level. The outside is cleaned off and the cone is properly weighed. The resulting weight is recorded in the second box
for the 2010 weights section, and then compared with the weight of the first box. If the second test is greater than 10 grams more than the previous weight, another round of the 2010 test is required. This process will continue until the most recent weight has a 10 gram or less increase from the previous test. Once your new weight does not exceed 10 grams more than the previously recorded weight, you may then copy your final result into column D, wet soil plus mold. The speedy test is used to determine the moisture content of the sample if it had been manipulated. Complete the computations through column H. The next step we'll take is to subtract the weight of the mold, column E, from the weight of the wet soil, plus mold, column D. We'll get the total weight of the wet soil, which we'll record into column F.
In this example, 4248, wet soil plus mold, minus 1973, the mold, equals 2275, wet soil. Next, we convert the wet soil weight in grams, column F, to pounds by dividing by 453.59. The formula is located under Note on the lower right side of the 0582B form, and record in column G, wet soil in pounds, to the nearest hundredth. In this example, 2275, wet soil in grams, divided by 453.59 equals 5.02, wet soil in pounds.
Then take the wet soil in pounds, column G, and divide by the volume of the mold, column C, to get the compacted soil wet, PCF, for column H, which you would record to the nearest tenth.
In this example, 5.02 wet soil in pounds divided by 0.0439 volume of the mold equals 114.2 compacted soil wet. If you need to obtain a moisture sample because you have manipulated the moisture content, whether you've added water or dried it out, you must proceed with a speedy test. When emptying the cone, strike the cone on the block upside down. Do not hit the side of the cone on the edge of the block. This may dent the cone and change its volume. If you need to obtain a moisture sample, empty the cone until you have reached the middle. You should have a mound of soil on the block that represents the middle of the cone. Weigh a 26 or 20 gram soil sample, depending on the size of your speedy, on the balance or electronic scale. Wipe the speedy cap to be certain it is clean, and put the soil sample into the cap. After putting 3 scoops of carbide into the body of the meter, hold the body so the soil and carbide won't mix. Put the cap in and tighten the top screw. Hold the speedy vertically. Tap the side of the body so the soil sample will fall into the body. Holding the speedy horizontally, rotate it so the soil and carbide will mix together. Hold the speedy at eye level and read the dial. Repeat the rotating and reading until the needle stops moving.
The needle is considered as having stopped moving after you have taken 3 consecutive readings that are the same.
In this example, the dial reading is 6.9. This is the Speedy Moisture Tester conversion chart. It converts the dial reading on the speedy to an oven-dry moisture content. Using the conversion chart, convert the dial reading, wet weight percent to oven-dry moisture content. In this example, 6.9 isn't listed, but it's between 6.8 and 7.0. You can see that the oven-dry value for 6.8 is 7.2, and you can see that the wet weight of 7.0 means an oven-dry value of 7.4. Because our wet weight is 6.9, we can say that our oven-dry value is 7.3. On your 0582B form, you'll record the oven-dry value in column B, moisture percentage. When a speedy is used to obtain a moisture percent, you need to indicate with an S next to the moisture percent value and circle the S, or you can also write out speedy off to the side. This will indicate that the material was too wet or too dry, and that it had to be manipulated, either by drying or by adding water, and that you had to use a speedy moisture tester to obtain a moisture percent volume between 5% and optimum for that material. Now you have the two required values, moisture percent and compacted soil wet, to take to the 1-point Michigan cone chart, used to obtain maximum density and optimum moisture for granular soils. Compacted soil wet values are located along the vertical axis, and moisture content values are located along the horizontal axis. Maximum density values are along the curve. First, locate your moisture content value on the horizontal axis, 7.3 from column B, and then draw a line straight up. Next, find your compacted soil wet value, 114.2, from column H, along the vertical axis. Draw your line from that point to the right. Where those two intersect, make a point. Next, from this point, draw a projected line along the diagonal axis lines. Where your new line intersects the curve will be your maximum density value. In this example, we come up with a value of 107.4. You'll record this value into column I in your 582 form. This represents the maximum density for the material you just tested. Next, we proceed vertically from the point on our curve back down to the moisture content axis. This gives us our optimum moisture content, 16.1, which will be recorded into column J on form 0582B. We can now finish the in-place density test that we ran previously. Record the maximum density of 107.4 to your column 10 above. Next, under the Proctor-Marshall button, enter the value of 107.4 into your gauge as a Proctor value. When that is done, the gauge will compare the maximum density with the dry density to give a percentage of compaction, which is recorded into column 11. This ends the presentation on the 1-point Michigan cone test. You may turn to the section of the Density Testing and Inspection Manual entitled The 1-Point Michigan Cone Test and review the material if you desire.